Welcome friends to my channel Civil Engineering Service. This is Ripon with you. In this tutorial we will be able to know about the shaped bearing capacity of R.C.C tight column. The shaped bearing capacity of R.C.C tight column. Then the size of the column 25 centimeter by 25 centimeter, and the longitudinal bar amount 6 piece 16 mm dia main bar, and given data: column size 25 centimeter by 25 centimeter, total rebar 6 piece 16 mm dia main bar, ultimate compressive stress of concrete F'(C) equal to 200 kg per square centimeter. Yield strength of steel Fy equal to 3500 kg per square centimeter. This information is given. For this information of a column, how much the bearing capacity of this column will be, this we will find out. In this tutorial we will find out the amount of bearing capacity of this column with this information. Okay. Required data: cross sectional area of column AG equal to 25 centimeter into 25 centimeter equal to 625 square centimeter. Area of steel, total steel piece 6 piece, and the area of one piece diameter of 1.6 mm 1.6 centimeter, 5 by 4 into 1.6 square centimeter. Then the total area of steel is 6 into 5 by 4 into 1.6 square whole square. Then we can get 6 into pi, the value of pi 3.1416 by 4 into 1.6 whole square equal to 12.064. Then we can get 12.064 square centimeter. Steel ratio rho g equal to area of steel divided area of the cross section. Steel ratio rho g equal to area of steel divided area of cross section of the column. Then we can get the value of steel ratio rho g 12.064 divided 6 to 5, 0.019. Then we can get 0.0193, which is greater than 0.01 and smaller than 0.08. We know that the steel ratio for a R.C.C column should be 1% to 8% by the code of American Concrete Institute (ACI). ACI, American Concrete Institute. Then in this column the steel ratio is 0.0193, which is greater than 0.01 and smaller than 0.08. That means the steel ratio is greater than 1% and smaller than 8%. Okay. Allowable tensile stress of steel Fs equal to 0.4 into Fy. That means the allowable tensile stress of steel is 40% of yield strength of steel. Okay, 0.4 into the value of yield strength of steel 3500. Yield strength of steel 3500. Okay, then the value of Fs equal to 1400 kg per square centimeter. Okay. Okay, now we will find out the amount of bearing capacity of the column. Known that the saved bearing capacity of tied column P equal to 0.85 bracket 0.25 A prime C plus Fs rho g bracket Ag. This formula is only for R.C.C tied column. Only for R.C.C tied column. The hints, the notation of this formula is P stands for the amount of axial load. 85.85 is for load factor. 0.25 concrete stress factor, compressive stress factor for allowable compressive stress. F prime C is stand for ultimate compressive stress of concrete. Fs allowable tensile stress of steel, rho g steel ratio, and Ag stand for the cross sectional area of the column, equal to 0.85 bracket 0.25 into the value of F prime C 200. This is the value of F prime C equal to 200 kg per square centimeter. Okay, the value of F prime C is 200 kg per square centimeter plus the value of Fs 1400 multiplication the value of rho g 0.0193 multiplication the value of Ag 625 kg. This is the value of Ag equal to 625 square centimeter. Okay. Okay, now 0.85 after multiplying 0.25 into 200 we can get 50.25 into 200 equal to 50 plus, okay, and after multiplying 1400 and 0.0193 we can get 1400 into 0.0193 equal to 27.02, okay, into 625 kg. 0.85 into, after additioning 50 and 27.02 we can get 77.02 into 625, okay, and after multiplying of this amount 0.85 into 77.02 and 625 we can get 40,916 kg equal to 40.91 ton. We know that 1 ton equal to 1000 kg. Then the saved bearing capacity of the column is 40.91 ton. Okay, thank you. And for getting more information and video, please subscribe the channel Civil Engineering Service and press the bell icon. Okay.